Here's another simultaneous equation question, part of core content. So very likely that it's going to be in the HSC and in all trials. Melissa knows the formula to convert Fahrenheit to Celsius is this. Again, it's that same formula. It appears a lot in the syllabus. Jason uses the estimate just to double the Celsius and then add 30 to find out the Fahrenheit. So instead of this formula he uses, I just double and add 30. At 31 degrees Celsius, by what percentage is Jason's estimate wrong? So this is the first question. So if we want to know what percentage he's off by, we need to know the actual temperature and Jason's estimate. So if we look at this, the actual temperature at 31 degrees is 9/5 times 31 plus 32, which is 87.8 degrees Fahrenheit. And Jason's estimate is you just double it and then add 30. So double 31, you get 62. Add 30, you get 92. So it's not a bad estimate. So that's the information we need. What's the question asked? By what percentage is Jason's estimate wrong by? So what percentage is it off by? So if we're looking at percentage error, this is like part of that measurement. So it's suddenly this question is bringing in things from the measurement topic as well. The percentage error is the error over the actual amount, and then to get to a percent, you times by 100. So what's the error? How far is he off? He's off by what? 4.2, I think. So it's going to be, what's he off by? What's the error? 4.2 over the 87.8, and then to turn it into a percent, you times by 100. So his estimate, what's the percentage error in his estimate? 4.78%. Okay. The next part of this question, Jason's estimate can be written as follows. F equals 2C plus 30. At what degrees Celsius does Jason's formula give the exact conversion to Fahrenheit? So basically, this is where we want, where those two lines, this straight line here and this straight line, that's where we want them to be intersect. We want to find the point of intersection. That's where the simultaneous equations come in. And what we know is that this is where the Fahrenheit is exactly the same. So we know that 2C plus 30 equals the Fahrenheit, and 9 over 5C plus 32 is the Fahrenheit. So here it is. At what degrees Celsius does Jason's formula give the exact conversion? Okay. So when is the Fahrenheit exactly the same? How do you solve this? Oh, well, because they both equal Fahrenheit, the next part is we just get rid of that middle part. So we get 2C plus 30 equals, and I've changed this 9 over 5 to 1.8 Celsius. It's just nicer to work with. We're working with decimals instead of fractions. How would we solve this equation? Because that's what we're trying to find. We're trying to find the Celsius that these two things intersect with. So we're going to minus 1.8 Celsius from both sides. And what do we get? And we're going to, instead of adding 30 on this side, when we take it over, we minus 30. So what we get is, oops, where have I gone? 2C minus 1.8C is 0.2C. 32 minus 30 is 2. So how do we find out what C is? If we times this by 5 and this by 5, we get C equals 10. So it's a bit hard, but really this step here is to write it as this and then get rid of that F, getting down to this line here. That's the hard part. Once you get down there, it's still difficult, but we should be a bit better with it. Okay, thanks.